Hello and welcome to another video for pre-calculus. In this video, we are going to discuss about polynomial and rational polynomial and rational inequalities. So in order to solve a polynomial inequality, what we do first is we'll make 0 on one side and put all the terms on the other side of the inequality. And then we'll change that inequality into an equation so that we get values for x. Okay, once we get those solutions, so those solutions are called the critical numbers, and we'll put those solutions on the x-axis or the number line. So we'll put those numbers on the number line. So those solutions will divide this number line into different intervals, and then what we do is we will have those intervals here. So we'll pick a number from each interval, and we'll test that in our inequality. If that number satisfies the inequality, then we'll take that interval as the solution. If it does not satisfy the inequality, then we ignore that interval and it's not the solution. And one important thing that we have to include when we write the solution is if we have the inequality which is greater than or equals to or less than or equals to, in those cases we have to include the endpoint. So we'll put the bracket. Okay, but if we have a strict inequality like this, then we don't include the endpoints. We'll write the open interval. So let's see example. It makes more sense when we do an example. So here is a quadratic inequality. So the first thing is we'll make 0 on the right hand side and we'll bring everything on the left hand side. So let's go ahead and do that. So for that we are going to subtract x from both sides, and then we'll subtract 3 from both sides. So when we do that, we get x squared plus 2x minus 8 is less than or equals to 0. So let's go ahead and factor this one because we can factor this easily. So we get x plus 4 times x minus 2 is less than or equals to 0. Now that was bringing everything on one side and making 0 on the other side. Now the next step, as we described earlier, is we are going to change this to an equation and find the x values or the critical numbers. So we'll do x plus 4 times x minus 2 equals 0. So we'll change it to an equation, and that gives us x equals negative 4 and x equals 2. So these two are the critical numbers, okay? Now what we do is we'll draw a x-axis or the number line, and then what we do is we'll take these numbers and put here. So negative 2 is on the left and 2 is on the right. Make sure that you put them in order. Now what we do is we'll pick a number from here and we'll put it into our inequality. So we can pick a number here. We can pick negative 5. Now if I pick negative 5 and if I put it here in my inequality, so negative 5 plus 4, so this would be a negative number, and negative 5 minus 2, this is also a negative number. So when we multiply negative times negative, we'll get a positive number. So if we pick a number from this interval and put it into our inequality, we will get a positive number. Okay, and then similarly, let's pick a number from here, from this next interval here. So let's go ahead and pick up 0 because that's an easy number. So if I pick 0 and if I plug it in here, so 0 plus 4 is 4 times 0 minus 2 is negative 2. So 4 times negative 2 is negative 8. So I get a negative number. Now if I pick a number from here, so let's pick a number 3. And if I put it here into the inequality, so 3 plus 4 is 7, positive 7. 3 minus 2 is 1, positive 1. So 7 times positive 1 is a positive number. So this also gives us a positive number. Now if we look at our inequality here, the inequality is this quantity here is less than or equals to 0. That means it has to be 0 or negative. So that means from this interval here, this interval cannot be in our solution because that's positive. This interval is not a solution because that is positive. So our solution is from negative 4 to 2, and then we have this inequality with less than or equal, so we have to include this -4 and 2 as well. So our solution for this inequality is -4 comma 2 included, okay? Or we can also write that in inequality notation, which is -4 is less than or equals to x is less than or equals to 2. That means x is in between -4 and 2, both the endpoints included. Let's look at another example. So here we are going to do the same thing. Let's put everything on the left hand side and make the right side 0. So for that, we are going to subtract 2x from both sides. So if we subtract 2x from both sides, so we get 2x cubed minus x squared minus 12x plus 6 is greater than 0. Now let's go ahead and factor this because we can factor. So x squared from the first two, so we'll factor by grouping. So x squared, then we get 2x minus 1. And then if we factor -6, we get 2x minus 1 greater than 0. Or our factors are x squared minus 6 and then 2x minus 1 greater than 0. Now the next step is we'll change this to an equation and find the critical number. So we'll do x squared minus 6 times 2x minus 1 equals 0. And then we solve this equation. So from here we get x squared equals 6 or x equals positive and negative square root of 6. From here we get 2x minus 1 equals 0, or if we subtract 1 and divide by 2, we get x equals 1/2. Now this square root of 6 is close to 2.44 and so many numbers. So we just need to write it that way so that we know what numbers we are going to pick up. Okay. So now let's go ahead and draw the number line here. Okay. And then let's put these numbers. Now we have three numbers here, -6, +6, and 1/2. So -6 is right here, -6. And then comes 1/2. And then comes positive square root of 6. Sorry, it's not 6, it's square root of 6. Now negative square root of 6 is -2.44. So we'll pick a number from here, which is, let's say, -3. Okay, from this interval, we'll pick a number -3. Now, if we take that number and if we plug it in here, so we get here in this inequality right here, okay? So -3 squared is +9 minus 6, so this is a positive number. Then -3 times 2 is -6 minus 1 is a negative number. So positive times negative is a negative number. So we are going to get a negative number in this interval. Now similarly, let's pick a number between square root of negative square root of 6 and 1/2. So let's pick up 0. If we pick up 0 and put it here, so we get 0 squared minus 6, which is a negative number. And then 2 times 0 minus 1 is a negative number. So negative times negative is positive. That means here we get a positive number. Similarly, let's pick a number from between 1/2 and square root of 6. So we'll just pick a 1. So if we take 1, so 1 squared is 1 minus 6. So we get a negative number here. And then 2 times 1 is 2 minus 1, which is 1. So we get a positive number here. So negative times positive is a negative number. So this gives us a negative number. Now on the right of square root of 6, let's take 3. So if we take 3 squared 9 minus 6, which is 3, which is a positive number. So 3 times 2, 6 minus 1 is 5, another positive number. So we get a positive number here. So now our inequality is this inequality says this quantity is greater than 0. That means we could have only positive numbers. That means the first interval here, so this is not the solution because it's negative. This is also not the solution. So the solution is this interval and this interval. But here we have a strict inequality. So what we have to do is we have to put a open interval. So our solution is this one and this one here. So we write it as solution of this inequality is from negative square root of 6 to 1/2, and then union square root of 6 to infinity. Okay, so that is our solution for this inequality. Now, to solve the rational inequality, it is very similar to the polynomial inequality, but when we look at the rational function, we have the numerator and denominator. So what we do is, first we move everything on one side and then make 0 on the other side, and then we'll make a single rational function, single fraction, in another word. And what we do is we'll find the 0 of the numerator. That means we take numerator separately and set it equal to 0 and solve for x. Similarly, we find the 0 of the denominator. So the numbers that we obtain from here are called the critical numbers. Okay, so they are called the critical values or critical numbers. Now we do the same thing. We'll put them in a number line. We check the intervals, and then whichever works is our solution. Whichever does not work is not in the solution. But one important thing here that we need to pay attention is, if the inequality is this, okay, we include the critical number from the numerator in the solution. But the critical number from the denominator, we can never include it, because no matter whether we have a strict inequality or we have this inequality with the equal sign, we cannot include that, because if we include the critical number from the denominator, it will make the fraction something over 0. So that's why we cannot include the critical number from the denominator in our solution, no matter what type of inequality we have. So let's look at an example here. So what we are going to do is, first thing, we put everything on one side and make 0 on the other side. So if we subtract 2 from both sides, so we get x plus 1 over 2x minus 4 minus 2 is less than or equals to 0. Now here we need to make a common denominator, so we have x plus 1 over 2x minus 4 minus 2 times 2x minus 4 divided by 2x minus 4 is less than or equals to 0. Now we have common denominator, so now we can combine this fraction. So x plus 1 minus 4x plus 8. So when we distribute here, we get plus 8 divided by 2x minus 4 is less than or equals to 0. Now, if we combine the like terms in the numerator, we get negative 3x plus 9 over 2x minus 4 is less than or equals to 0. So that's the first step. Now the next step is we'll find the critical values by solving the numerator and denominator separately. Okay, so what we do is we'll take the numerator. So let's write numerator here. Okay, and then what we do is we take that negative 3x plus 9 equals to 0, and then we solve for x. So subtract 9 on both sides and then divide by negative 3, so we get x equals 3. Similarly, we'll take the denominator and then we'll set it equal to 0, and then we'll solve for x. So let's take the denominator, which is 2x minus 4, and set it equal to 0. Subtract 4 on both sides and divide by 2, so we get x equals 2. So these are the critical numbers. So let's go ahead and draw the number line, okay? And then we have 2 and we have 3. Now let's go ahead and pick a number. Let's pick a number from here. So from here we can just pick a number which is 0. So if we pick 0 and if we put it here, so negative 3 times 0 is 0, 2 times 0 is 0, so we get 9 over negative 4, which means we'll get a negative number here. Okay, and then between 2 and 3 we can pick a number which is 2.5. And then if we put it here, so negative 3 times 2.5 plus 9 over 2 times 2.5 minus 4. So if we do that, we get a number which is negative 3 over 4. Okay, so which means, sorry, we don't get negative 3 over 4. Sorry, what we get 3 times, this is positive number. We get positive, so we get a positive number. So we get a positive in the numerator and then we get a positive in the denominator. So both are positive, that means this is a positive number here. Now, from the right side, let's take 4. So if we take 4, so we get 4 times negative 3, 12 plus, so we get 3, negative 3, and then we get 4 times 2, 8, so we get a positive number here. So negative over positive is a negative number. So we get a negative number here. That means if we look over here in our inequality, so this says this this number here, okay, so this quantity is less than or equals to 0. That means it cannot be positive. So, which means this is not in the solution. So our solution is here and here. Now, here we have less than or equals to. So what this says is the critical number that we obtain from the numerator, we can include that in the solution, but the critical number that we obtain from the denominator, we cannot include this in the solution. So when we write the solution, we have to be a little bit careful here. So 2 is a critical number that we obtain from the denominator, so we cannot include this into our solution even we have this less than or equal sign. Okay, so it's negative infinity to 2, and then we have that open interval union. Now we can include 3 because that's the critical number that we obtained from the numerator. So 3 to infinity, and this is our solution. We'll just do this much for this video. I'll see you again in the next video.